going to talk about regression with a silly example, just to illustrate what controlling for a variable does in comparison to not controlling for it or testing an interaction with it. In this example, I made some fake data. This will always generate the same fake data because I set the random seed here. If you want me to go through, I think people often do want that. I'll just walk through the lines of this code just to, even though it's not the main topic of the day. So this line just sets the random seed so that the next few random numbers that I generate will always be the same. So they're not they're not random anymore, but they're pseudo-random, and they will be good enough for us in this case.
Sarah, can I actually ask a question about that? Because I know we've talked about it before, but I still can't wrap my head around it. So if I run this code on my own computer, because it has set seed, it'll still be the same numbers?
Yeah.
And
as long as you run it in exactly this order, right? So set seed just means that like the sequence of random numbers that get generated will be the same from here on out. But if you generate even one random number out of order, then from that point forward, it will be completely different from what I would have.
And does 205 mean something in particular? Like, is that a specific random set?
No, I just, I started at 200 arbitrarily, and then I plotted it, after I'd written the code, I plotted 201, 202 up to 205 because I liked the way that plot looked best. I just thought it was more aesthetically pleasing. I chose 205.
I think I understand enough to be able to use it for purposes.
Yeah,
so.
I mean, right, you don't need it really. It can be useful if you want someone else to look at your example and see exactly the same thing, and it can be useful if you're doing some kind of simulation and you want to keep track of how you got the exact results that you got. So that's what that does. And then this line creates a new data frame that has one variable in it called borks that is just missing values for 200 rows. That's just to get the data frame the right size, 200 rows, so that the other variables I make will fit in it nicely. And that data frame is called dat. Then I make a new variable in there called dog that is the result of this concatenate command that just repeats the phrase big and fluffy, 95 rows, big and scruffy, 20 rows, small and fluffy, 25 rows, and then small and scruffy for 60 rows. And the reason I did that is because I wanted, I'm not going to use that variable for anything, but I split it into these individual variables for the size and fur of each dog in the data set. I should have called it doggo. I wasn't thinking. And I just wanted like about this many of each of those combinations. So I just decided to start it off with the combinations instead of figuring out how to set these other variables so that it would come out to that many of each type of combination. Then I create this temporary variable. This is maybe the most complicated line here. I take that dog column as a vector, right? This is a vector of strings, and I'm doing stir split on it. And I'm splitting on this sequence of characters, space and space. So the result of this stir split line is going to be a list of vectors of strings. Let me just show you what it is. I'm going to run that alone. It's a list of 200 vectors of 2 strings each that have the first word and the last word of each of the individual observations in the original string vector that I split. But this is a list, so it's not that useful to me for what I want to do with it. So the first thing I did is unlist it, which turns it into this alternating vector, which is also not great, right? This one is length 400. So this dog was small and scruffy, but those are just treated as 2 separate items in this vector. So then I put them in a matrix by row with 2 columns, which results in this matrix where the first column of the matrix is the sizes, right? Sorry, I keep scrolling past the top of it. The sizes, and the second column is the fur types of each of these 200 dogs. So that I store that matrix temporarily in this variable temp, so that then I can assign a new column to the data frame size that's just the first column of temp, which we know is either big or small. And I converted it to a factor in order to do that. Just for convenience later, yeah.
Could you have also just done 2 rows of the repetition line? The first row being like size and 95 big, 20 big, 25 small, and then the second line of that code being like 95 fluffy. Like would that, is that what you were doing here, like making
yeah,
those
I totally
2?
could have just started off by assigning size and fur, and then having there be 115 big followed by 85 small, and then 95 fluffy, 20 scruffy, 25 fluffy, 60 scruffy, and it would have been totally fine. And in fact, probably simpler, but I wanted to think about it this way first. So this is just like how my mind was working and why I.
It makes sense. I just wanted to make sure I understood what you were doing, like from the way my mind was working through it.
Sometimes there's many ways of doing things, and some of them might be needlessly complicated. Then the next thing I did was I took size and replaced it with a copy of itself that has been re-leveled so that small is the comparison group. By default, the converting the string to a factor will make the first one in alphabetical big, the reference category, but I just want it to be the other way around for later, so I changed it. And then fur, I did the same thing. I converted the second column of strings to a factor. And that one I'm okay with the default reference category of fluffy. So finally, I fill in Borks, right, which was missing, 200 missing values originally up here. But now I'm overwriting it with this new information. I guess having this as a single variable makes this slightly easier instead of having to do ands with multiple conditions. So what this does is it creates a vector of random integer values drawn from a binomial distribution. There are 200 of those values. Each one is, you could think of as the result of 90 coin tosses added together, where the probability of heads on the coin tosses depends on which of the 200 trials you're on. So the probability will be 48 if the dog is big and fluffy, 48%, 0.48. 21% if the dog is big and scruffy, 66% if small and fluffy, and 24% if small and scruffy. And the reason that works is that this statement, dog double equal sign big and fluffy, returns true only in the case where the dog has this string as in its value in that vector in the data frame. And when you try to do math with trues and falses, the trues are 1s and the falses are 0. So this 0.48 becomes 0 in all of the other cases, but 0.48 in the case where the dog is big and fluffy. So in that case, I'm taking 0.48 and adding 0 and 0 and 0. So the probability is 0.48. In the case where the dog is big and scruffy, I'm taking 0.21 and I'm adding 3 zeros to it. So this is just my shorthand way of making the probability of a Bork depend on what kind of dog it is. I say the probability. So I'm thinking of Borks as this, I'm going to treat Borks as a continuous variable, right? But because I called it Borks, I thought that the values should be integers. So I decided to make it like each dog had 90 opportunities to Bork and only Borked some of them, and we counted how many times they did. But we're just going to treat it as a continuous number for the purposes of the example today. Not that all of that was not the main reason for this meeting, but I just, when I show people code, they sometimes want to know what all the parts of it are doing.